This lecture is about reading the Z table. So in this video, we will learn how probabilities can be extracted from the Z table. But first, let's do a quick reminder of what is the Z. So you should know by now that if you have a distribution, I'm going to start with the normal distribution. So if you have a normal distribution and you're interested in calculating a probability of values between 2 points, then since you started with the normal distribution, this being normal, with mu as the mean and sigma as the standard deviation, then there is a possibility for you to turn this into the Z, which is the standard normal. And standard normal basically is a normal distribution that has a mu of Z exactly equal to 0 and a sigma of Z exactly equal to 1. Okay, so I'm gonna go back and throw it again to make a good understanding of the Z. Okay, so what you should know about the Z, the Z has a normal distribution and it's centered right at 0, and having a sigma of 1 means that if you go one standard deviation up, you reach value 1, another standard deviation you reach value 2, a third standard deviation you reach value 3, and then 4. Similarly, going down, that's a -1, -2, -3, and -4. But you should also have a pretty much an idea that by the time you have reached 3 or maybe 4 standard deviation up and 3 and 4 standard deviation down, probably there's nothing left. And therefore, the majority of the area is kind of captured between -4 and +4. So what statisticians have done is that they decided to do the following. They decided they're going to start with a very, very low value of Z, almost at 4, almost. So in fact, they're going to start at the -3 point, I guess it was 89. And then they're going to go up. And what they did is they decided to calculate the probability below that point, so like this tiny area, and then they started pushing up the limit up, so going from -3.89 all the way up to 3, recalculating the area, all the way up to -2, calculating the area, -1, calculating 0, 1, etc. Okay, so obviously the more you push the Z from the -4 approaching the 4, the area is going to grow from a very, very small probability, something like 0.000 maybe. I don't know how many zeros, and then 1, like for this tiny area. And by the time you reach the 4, where you're calculating the area below 4, you probably have reached like 0.9999999, or maybe an area of 1 if you want to round up a little bit. Okay, now then the question becomes like, so let me write it up. So what they calculate is the probability of the Z less than, and remember we can put it equal, it doesn't matter, the value, and they get you the area for that, yani the probability. Okay, and this value right here, it changes. So it started up with the smallest being -3.89, and then they push it up till it reaches the highest, which is +3.89. Okay, and so the other thing I want to tell you is that when they started pushing these values, they push it at the level of the second decimal point. And if your first value is -3.89, the next one is 3.88, and then -3.87, and -3.86. So you can appreciate how many times they're changing the Z value at a very tiny pace, very, very tiny. And the more they they push the Z up, the bigger the area becomes. And they're doing it, is again, as I said, at the level of the second decimal place. So going from negative 3 point, let's say 89, to all the way to negative 3.80, they've calculated 10 areas. And then from negative 3.80 to negative 3.70, command, they're calculating 10 areas every time. So you can see that almost going from negative 4 to negative 3, they will calculate about 100 areas and about 100 probabilities. And these are cumulative probability. And a kill probability actually include the one previous to it. And then going from negative 3 to negative 2, another 100 areas. And from negative 2 to negative 1, again 100 areas. And from negative 1 to 0, another 100 areas. So you end up with 100, 200, 300, 400, 500, 600, 700, about 800 areas. So again, as they're pushing then the Z from negative 3.89, which is the smallest value they picked up, all the way to the largest value, which is 3.89, and this is the Z. And as the area obviously goes from 0.0000 all the way to almost 1, between these two values, they've calculated about 800 cumulative probabilities. Okay? Yani by the time they reach Z less than or equal to 1, then what they're calculating is all of this. Okay? And I'm hoping by now you know that when you reach that less than or equal to 0, be it a symmetrical distribution, the normal distribution is symmetrical distribution, and knowing that 0 is actually the average, the mu of that, then the area below 0 is obviously equals to 50%, yani 0.5. Okay? Now, having said that, the issue becomes then, well, okay, if I have 800 areas, 800 probabilities, for 800 different Z values, how do I tabulate them the best way possible? And the answer to that is that they figured out what they can do is use some sort of stem and leaf approach, meaning what they would do is they would start with a Z, let me use a different color, of negative 3.89, but instead of putting the 9 next to here, they put the 9 here, okay? And then negative 3.88, they put the 8 here. And then negative 3.87, they put the 7 here, all the way down to 0, meaning by joining this stem with this leaf, and this being the second decimal point, you will get the actual Z value. And whatever you see under would be the probabilities. Okay? So joining this to that will give you the Z, and what is inside is actually the probability. To make this clearer, what they decided to do is add a 0 here, and instead of just writing 9, to put 0.0 with a negative, so that you know that this is the second decimal point and it's negative because this is negative. And then the next thing you're going to do is you're going to move to negative 3.7, and then you have the 9, the 8, the 7, so you get another row of probabilities. Every row is made of 10 probabilities, and then negative 3.60, so this is 70, and you get 10 probabilities, and you do that all the way till you reach the last one, which is 0.00, which means that the last entry for that page is Z less than or equal to 0.00, and therefore this is going to be the 50% right there. And all of this is put on one page, which is the negative page of the Z, and then they do exactly the same thing on another page, which is the positive value of the Z. So I'm gonna go directly to the Z. Here we go. So as I told you, you have a stem that is showing right here, negative 3.80, and then you have the negative 0.09, negative 0.08, all the way to 0. And the first column and the last column are just repetitive. So if if it's easier for you to look at this one or that one, it doesn't matter. Okay, and as I told you, you have 10 probabilities inside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the z is gonna grow from negative 3.8 to negative 3.7. You know, it's growing like negative 60, and it's growing till you reach the last row, which is the 0. Okay, so this one ought to be read as z negative 0.09, negative 0.08, negative 0.07, all the way to reach z0 exactly. Okay, and that's why you have a 50%, because that's half of the area. Okay, remember what's inside are the probabilities. And then you move into the second page, which when z starts becoming positive, and sure enough, the first entry is 50%. That's z00 with the 0. And then here they're no longer negative, now they're positive. And another thing you ought to note that you're starting from the 0 on this side, moving to 9 on that side. Okay, so again you have 10 probabilities, and the z will increase till the last entry, which is 3.80, and the last one is actually for 3.89, which is the last one right here. Okay, and you almost hit the 1, the 0.999. Okay, so so this is how they were able to produce about 800 areas in only 2 pages. And it's your job as a user of the Z table to recognize the fact that if you're looking for a certain Z, you have to match the first column or the last column, it doesn't matter, with the top row. So it's like these are the stems and these are the leaves. By by combining them, what you will find inside is the cumulative probability. So like this is 0.40 and this is 0.05. So combining these two together, this is the area for z less than or equal 0.45. So maybe the easiest thing to do now is to do some examples of how you would be using the Z table. In this video, I will not use the calculation. This is just about the Z directly. So let's suppose you are interested in calculating what is the probability of Z less than or equal to 1.116, for example. Okay, now remember, the Z has a normal distribution and it's centered at 0. On this side, the Z values are positive. On that side, the Z values are negative. The Z values, not the actual probabilities. The probabilities, you already know, they're all positive. However, on this side, you can predict that the cumulative probabilities are going to be less than 0.5, whereas on this side, the cumulative probabilities are going to be greater than 0.5. In this specific example, you're looking at a Z of 1.16, and since you're so I need to correct this. This is actually less than or equal. And so since you're interested in less than or equal to 1.16, and therefore you're interested in looking at the area below that value, and this is given to you directly from the table. The table always will give you less than or equal to the value you're looking for. So what we do is you go to the Z and you start looking for the 1.16. As we mentioned, it starts with 1.1, so that's the 1.10, and you have to tie it up with the 0.06 right here. So by tying up these two, you're going to find right there a value of 0.8770. This is the probability you're looking for. Okay, so this is equal to 0.8770. Type. What if you were asked to actually calculate the probability of Z greater than or equal to 1.16? So what if in fact you are more interested in this area right here? So again, remember the table does not give you greater than or equal. So you're going to have to do something. And here you're given two options. Option number one is you take the Z So you write Z and you flip that sign so that it's less than or equal, so that you can actually use the table. And what you will do is you will change the sign of whatever you had over here. You're going to flip the sign. So as you flip this, you're going to have the flip the sign. So it will be negative 1.16. And these two are exactly equivalent. And if you think about it, the negative 1.16 is this, the dark red, and the dark red is exactly equal to the light green there, because the Z is a symmetrical distribution with the symmetrical being at 0. So that's option number one. Option number two, what you can do is you can actually كمان مثل ما قلنا, you write your Z and you have to change the equality, so you have to write it as less than or equal to be able to use the table. However, this time you don't change the sign, you leave it as 1.16, but what you will have to do is write a 1 minus. Okay? So basically what you're saying this light green area right here, this is actually the entire area, all of the area, minus the yellow area. And that yellow area is what we discovered here, what we calculated here. Okay? Okay, with more explanation on the Z. So when you're working with the Z, it's going to end up always in these are the, I'm going to write down the possibilities. So possibility number one, you get a Z less than a certain value. So it could be like negative 0.34. And this is a direct reading from the table. So as long as it's less than, you're fine. Option number two, you get Z less than a certain value. So it could be negative 0.34 or whatever the value is. And here, as I mentioned a minute ago, then you have two options. Option number one, you're going to write it as less than or equal, and you change the sign so it becomes positive, and that is a direct reading from the table. Or you also flip the sign so it's less than, but you keep it negative. However, you need to do something so that you don't lose the actual value, and that's the 1 minus. Okay. Option number three, the things that you might encounter working with the Z is you may encounter where your Z is actually between two values. So your Z could be between, let's say, so 2 and 1. Notice we always write it to the second decimal point because the table is given to the second decimal point. And throwing in the equal here will not change anything, so I like to have the equal. Here what you're going to do is, first let's look at it visually. If this is your Z distribution, centered at 0, okay, and if this is 1, and if this is 2, obviously you want what's in between. You want what's in between. You know that the table does not give you in between, but the table will give you, if you look up value 1 or less than or equal to 1, you're going to get all of this, which is not what you want. However, if you look at 2, you're going to get all of that, which is the part that you want with the part that you do not want. So once you figure that out, it becomes clear that all you have to do is basically get the larger area minus the smaller area. The larger area is actually nothing but the Z less than or equal to the larger value of the 2. And then you do 1 minus the Z less than or equal to smaller value of the 2. And you can actually get this from the table because it's less than or equal, and you can get that as well from the table because it's less than or equal, and this way you can get your answer. So this is scenario number one, scenario number two, scenario number three. I think that covers all the possible scenarios. You're not going to get more complicated than this. The last thing that you may have to do is you are actually given the area, and from the area you need to find Z. Okay, so for example, you're told that the probability of Z is less than or equal what value, so that you get a total area of, for example, 95%. That means that if this is the Z distribution, again centered at 0, you need to find that value, which obviously has to be somewhere here, so that the shaded area, the entire shaded area here, is equal to 95. Okay, so let me show you how you do that. The way you do that is you go to your table and you're actually looking for an area of 0.95. Okay, a common mistake is for students to come and look Z95. يعني هذه 95 هيك. No, that's not what you need to do. What you need to do is to find the area 95. So that, for example, is area 9115, which is too small. And by now you know that going right and going down increases the area. So let's go down. 93 is still small. Okay, 9505 is pretty close. However, let's back a little bit back. Let's back down a little bit to see if we get a better estimate. If I back down a little bit, I will find 9495. Both of them are the closest value to 95 exactly, so either would work. Okay, so both of them start with 1.6. This is so 60, 61, 62, 63. This is 64, and this is 65. So either of these two, either 1.64 or 1.65 would do. If you pick 66, it would be too big because that one is a better one. And if you pick 63, come in, it would be too small because this one is a better one. So either 164 or 165. Similarly, if you are asked show the probability that of what Z such that Z less than or equal a certain value is لنقول 20%. So now you know that you're looking for a Z that has to be here, so that the red area is 20%. Okay. So exact same approach, but this time we're going to look at the negative side of the Z. Okay. So again, you go back to your table, go back to the negative side and start looking for 20%. Again, don't look for Z20, look for the area 20%. By eyeballing the data, I can see that this is pretty close and that is also pretty close. Okay. Obviously, this one is a much better one than that one because it's closer to 20%. So if I pick this one, this would be negative 80. Remember, when you're on the negative, the 9 is first. So negative 89, 88, 87, 86, 85, 84. Negative 84. Okay? So that is going to here, you're going to have negative 0.84. Okay? And you can have anything, like I can say Shuluk probability that Z هالمرة مش less than, greater than or equal certain value, and you get مثلا 60%. Okay, now if this is the case that you have, يعني you want 60% to be above that certain value here, right? That means that Z is somewhere here, so that the orange shaded area is 60%. طب إذا orange shaded area is 60%, قد إيه بيكون below the area? 40%. So you can easily say, well, we know that that means that less than the same value right here. However, I changed, right? So بدل ما تكون greater عملتها less than is equal to 1 minus, remember the 1 minus 0.6, and that gets you 0.4. So now you're looking for an area of 40%, and that you will get you the Z. And so on and so forth. So this is the all kind of things that you're going to get. A final word about the Z. No matter what you're doing, if you are looking for a Z less than and that is equal to 50%, then, I mean, you can look it up in the table, but you do not need, you should know now by heart that the Z is symmetrical. And right here, right there, if you take this piece, right, the half of it, okay, that's the 50%, meaning that this value is going to be 0.00, okay? Z less than 0.00 is going to be 50%, because remember, the mu of Z is 0.00. Sigma of Z, coming to remind everybody, is equal to 1.00. Okay, so this video concludes using the Z table, um, how to read the Z table and how to use the Z table, provided that you're able to turn a variable into a Z. Thank you.